We will start the last session of today. It is a pleasure to introduce the plenary talk of Paul Drijvers. You all know Paul, who is professor at Freudenthal Institute at Utrecht University in Netherlands. His research on ICT and teacher professional development is well known internationally, so it is not necessary to present. What you might less know is that Paul is also research scientist at CITO. At which he is involved in working on issues of assessment, evaluation. So I think he will tell something about this. And so it is at this topic he will share with us his reflections on digital assessment of mathematics, the issues, opportunities, and criteria. So I hand over to you, Paul.
Thank you very much. So good afternoon. Thank you very much for coming. And merci Jana for these kind words and the kind invitation to speak about assessment, which is quite a challenge in general and for me in particular, because I don't feel such an expert on the topic. But let me give it a try. And maybe, well, as a result, this talk is a bit global, I would say, and not a very deep one. And it contains only two main messages, which I will tell you now so that we've had that for. So, my first main message is that, in my opinion, we really should take assessment, testing, in the traditional sense of the word, like written, individual assessment and testing. We should take this really very seriously. My opinion, I may be wrong, but my opinion is that we here as a research community, we are much more interested in learning, and we are interested in innovation and in expressive tools, Kroon has mentioned, and in dynamic representations and interaction and higher order thinking. This is what we like, right? But reality is different outside. Outside, the educational world is driven, like policymakers, textbook authors, teachers, are driven by traditional, individual, summative, written assessments. So let's face this. I'm sorry, life is hard. That's the first main message. My second main message is that once we agree that we take a more careful look on this, I'm not sure if you do, but supposedly, there's a lot we miss, because assessment environments are not designed for assessing mathematics. So what we miss is all the environments that provide construction room to students, that provides mathematical means to express themselves, to explore all the things that we do like. So, I think it's important that we really work on thinking about how to extend the traditional assessment environments and the traditional assessment practices in the directions that we all like and that we discuss here during this conference. That's my second main message. In fact, we could end now. Okay, but now that I'm here, and I like to be in front of all of you, I will say a bit more about this. This is the outline, the menu. We are in Lyon, so let's call it the menu. And the main course, the plat de résistance, is the fourth bullet, the opportunities, the more positive parts, I would say. But first, let's set the scene, sketch the landscape, and to make sure that we are all on the same page. So some very general points here. Assessment. What do we want for assessment? A good test should reflect previous teaching and learning, should offer opportunities to students to show what they can do on different ways, different levels, and should be valid and reliable. Okay, we all know this. And assessment can have different functions. The summative function, assessment of learning, the more formative function, assessment for learning, which was so nicely discussed in this wonderful FastMed project this morning. And maybe as a sub-part of the formative one, the diagnostic assessment as learning. I will use those words. And relatively new in the field after centuries of traditional assessment is digital assessment, and which I abbreviate as DA. And the point is that it is really upcoming and will be omnipresent very soon. Think, for example, the eTIMS 2019. So TIMS will be delivered online in a digital form. PISA 2015 already was administered in digital form. And many of us will know about national initiatives to change summative tests or formative examinations at different levels into digital formats. So if we like it or not, this is what's happening, and we should, well, deal with this. This is an example from TIMS. I think it was Kronis who showed us this balance example yesterday, which was very nicely, interactively. This is a very static one with a traditional multiple choice question. So how could we make this type of items more lively and more relevant to students and more valid and reliable than we can do here? As an aside, I would like to notice that what is interesting in TIMS is this assessment matrix, that they have a two-dimensional framework, one with the domains within our topic, number, algebra, geometry in this case, etc. And another dimension with some more less concrete ideas like knowing, applying, reasoning. And it's these type of two-dimensional matrices that can really help us to design our assessments and our tests and to underpin the way we do it. And this is something that's typically from assessment practices. And sometimes mathematicians or math educators are not so much aware about what's happening in the assessment world. So therefore, maybe superfluous, I show this to you. PISA 2015 was delivered or administered already digitally. There are no released items for mathematics, so there's not so much I can show here. But for example, here you see something, and there's an open answer box here. So it's not multiple choice, but it's an open answer, but still a very closed and limited environment. Also, as an aside, the assumption for PISA is that the old paper and pencil items that they have been using for years, which are now transferred in a digital format, that the psychometric characteristics of these items do not change, which you might question. And all PISA is based on that. So if your country didn't do so well in 2015, you have an argument. All right, if you look at the traditional assessment cycle, which is used sometimes in some literature, you can notice that in all aspects of the cycle, in the design, in the construction of items, in the administration and delivery, in grading and scoring, in analyzing the results, in setting standards, in all these phases, digital tools can and do help, or can be used. So digital assessment really has an impact on the complete assessment cycle. I would like to distinguish between assessment with and through technology or digital tools. And this is based on Stacey and William and the recent ICMA topical survey. And, well, Bearable is the only co-author here, I guess. The with refers to the more traditional testing formats during which students have access to digital means. Like, for example, national examinations with graphing calculators. I think that's what you have in Portugal at the moment, and in the Netherlands as well. Through digital technology goes further than the delivery is through digital means. So there's no paper pencil involved anymore. For example, the PISA test. Okay, so those were a final one. Digital assessment environments or tools. The way they come to you is usually in the form of the assessment player, the player environment or the delivery module, but there's much more needed. For example, you need an authoring system in which you can design tasks. You need some content management system in which you can manage all the different tasks that you have already created. You need a way to monitor the students' progress, particularly when you are interested in adaptive testing. And you need some scoring or reporting module, unless you want to do this by hand. And there are some other possible. So this is not very strict, but this is just to make sure that you are aware that a digital assessment environment is more than just a player. Okay, I think this was some very straightforward things to make sure that we're on the same page. Okay, now, why would we engage in digital assessment for mathematics? There are some well-known arguments for that. The delivery argument, which means that it's nice to have digital assessments because you can do it at any place at any time. The production one, it's nice because when I have to make a new test, I can easily compose it from existing tests and existing item collections. Feedback, I can use, and this is more for the formative, of course, I can use the online environment to create more or less intelligent and helpful feedback to students. The scoring, we can use digital means to automatically score student responses. We can use digital environments for adaptive testing so that students who do very good are not annoyed by too simple, too easy tasks, or students who do not do so good are not getting frustrated by tasks that we know beforehand that they will not be able to finish. And the anachronism argument, which means that the world is full of smartphones, tablets, computers, etc. And education is getting full of those devices. So testing without such devices would be an anachronism. And finally, the outsourcing argument that you might hope that once you have digital tools available, you can focus your testing more on interesting higher order thinking skills rather than the basic work. Again, the same references. The first arguments are particularly valid for assessing through technology, and the final two are also valid for the assessing with technology case. So this is why we should do it. But there are some issues. Here you see a task in Dutch, but there's a lot of mathematics in it, so you will understand it. This is a test for pre-service mathematics teachers who finished 4 years of teacher training, and then at the end have a mandatory kind of final national test. And if they fail, they are not allowed to go to teach. So this is a high-stake test to them. And it's a digital test, an online test, and you have a triangle here and an angle and some magnitudes here, some length. And the normal question here would be, what is the length of BC? Because that's what you don't know here. You see the point? Calculate BC. However, the task is BC, we call BC the square root of k. And then the question is, on the bottom, what's the value of k? Now, why on earth would one be interested in the square root of k? I just want to know what the value of BC. Well, the point is that this assessment system was not able to work with square roots. So the test designer said, oh, we can find a workaround. We will not ask the answer. We will ask for what's below the square root sign. And this is definitely a question that from a mathematical point of view, yes, Jos?
But you couldn't assess the number with 5 or 6 digits. So it would be a very strong coincidence if someone...
That could be an alternative. But still, we are clearly not in a numerical approximation mode. We are here in exact algebraic mode. So we want the square root of k as an answer. So apparently the limitation of the assessment system led to raising very artificial questions. So this is a non-example in my opinion. Another example, same test, a system, 3 equations with 3 unknowns. And of course the task would be, please solve the system. And then the natural answer would be, please provide the values of x, y, and z. This is not the question. The question is, please give the product of x, y, and z. Why would we be interested in the product? And also, it could be that the product is correct, while the solutions are not correct. But anyway, why are we interested in the product? Well, we are not. But again, this automated grading system could not deal with 3 answers simultaneously. So each item can only have 1 answer. So this is why the test designers chose this artificial question. Now, again, a non-example, right? And this system, this was question mark perception, is really a great player worldwide in the field of assessment. So if we neglect the mainstream assessment world, they will never go beyond this level. So this is something we should do, I feel, right? So far for the non-examples. And the issues are, well, I already said it to a certain extent. Students are, I don't know the English word for that, but they cannot move in the environment. They can just press a multiple choice item or enter a number, and they don't have any space to act, to produce, to construct, to show what they can do in many digital assessment environments. And that's a problem. And also, designers therefore go and do strange things, as you just saw. And we also, of course, would like to have some intelligence in the way student responses are interpreted. So those are the issues. Now the opportunities, now the good news. Well, good news, it's limited good news, and we are still struggling with that, but maybe you can tell me afterwards that there are better examples. 4 cases, very short, the Finland case, very short, the Dutch national examination case, a bit longer, the Dutch digital diagnostic test, and very short again, the digital math environment. So first, Finland. What they did in Finland is they created an examination player, an assessment player, which is called Abiti. And within Abiti, so this is a test through technology. It's an online test for students. And within this environment, students have access to GeoGebra, K-Calc, Maxima, Casio ClassPath, and TI Inspire. So these students really have, well, very good mathematical tools at their disposal, which they can use, they can choose. And during the teaching, I guess in schools, some of the teachers use TI Inspire extensively and others use Casio ClassPath extensively, so students can use their favorite tool, work on it, and make a kind of a screen copy and paste it into their digital worksheet. And what I like here is that students have really full-fledged expressive mathematical tools at their disposal. And this is delivered in this bootable client lockdown system, which means that the computer is like, you cannot get outside the Abiti system, and this is within the Abiti system. Schools either have facilities for this type of testing, or students bring their own device, I don't know exactly. But this is interesting in my opinion, because we don't have these stupid limitations that I was just discussing. And the only disadvantage probably is that this needs human scoring. So the teacher sits behind the screen after the examination and will grade work. So far for Finland. In the Netherlands, we have a similar discussion if we speak about the 18-year-old national examination, which is summative. In our case, so far with technology, and so far with graphing calculators. But this is a bit of a debate going on. First, because graphing calculators is kind of, well, old school technology, you might say. And otherwise, because students come with different apps and they have examination modes, but teachers are unable to verify this, so there's always a lot of debate on it. So we're thinking about a transition towards first GeoGebra and then maybe other tools which are embedded in our national examination assessment player, which is called Facet. So the Dutch variant to the Finnish Abiti. And again, if this would work, students would have access to, well, a tool that they hopefully are familiar with and that they can really use and to do some more advanced mathematics than I, as test designer, have in mind. This is just under consideration at the moment. It's not yet decided. Now, the third example of opportunities. An aside. This is just really an aside, but what we have now in the Netherlands is that a full psychometric analysis of the national examination is available online. Here you see a picture of that. And teachers have access to this, but also have access to their own students' results in the same report. So as a teacher, if you are, well, you know a bit about these results, what's the p-value, what's a adapted reliability. If you know a little bit about this, you have access to a lot of data and you can see what your own class or your own school did. And you can see, well, on the geometry task, we didn't do so well at the national examination compared to the whole country. So I should adapt my teaching maybe. So I like this psychometric approach very much. And I think that mathematics teachers and math educators and math researchers should know a bit about this to benefit from it. An aside, sorry. Now, my third case for opportunity is the Dutch diagnostic test. And that's for 14 to 15 years old. And the aim is to provide students with some diagnosis of what is going well and what's not going well in the light of their national examination 3 years later. It's an adaptive test and based on the intermediate learning goals that Jos invented, I guess, at the national. Okay. I'm going to show you some examples. I'm going to first discuss the architecture because that was complicated. This is Facet, the national assessment player. And of course, when they designed Facet, they didn't think about equations because they didn't think about math. So my main job during quite a while was to insist on, to tell them that we need an equation editor if we want to assess mathematics, which at the end succeeded. Then you have a separated authoring tool, Questify, again, in which we needed some additions to make it suitable for mathematics. And around this core, we built some other things. We used, from the digital math environment, we used the graphing module, because I said, we need graphs in our tests. Okay. We embedded GeoGebra for geometry. And we embedded a computer algebra system, which was Maxima in our case, especially for automated scoring. So students can use these two, and students are not aware of this, but as a test designer, you are very aware of that. That was the architecture, and just a simple example here. You see a triangle, a rectangular triangle, A and B, and you have 4 of those triangles and you make a puzzle out of it. And the question is, could you find an expression of the area of the whole big square? Right? Now, this is not straightforward for 14 to 15 years old, at least in the Netherlands, because there are no numbers in it, and that's always hard. So one of the correct solutions would be the easiest one, a squared plus b squared, because, well, this is a square root of a squared plus b squared, and you have to square it again, right? But if you enter this, it is graded as correct. But if you have another type of reasoning as a student, you say, I have 4 triangles. Triangle is in half a times b plus 4. And then I have in the center a small square. This is b minus e. So as a test designer, I decide, okay, this is correct as well. But I don't want to think, I don't want to calculate, you know, mathematics a long time ago. So I just want to say to the system, okay, this is the correct answer, and every other equivalent answer, whatever students invent, is correct to me. So if students add a +1 and a -1 here, I don't mind. So that's why where we need a computer algebra for. So all this is correct. Second example, and I'm going to, because it's maybe more lively, I'm going to try to show you this in reality. So can you hear me say this way as well? Are you going to stay here all the time?
Yeah.
Oh, then maybe stand on the other side. Thank you, Christian. So what I'm doing now, at least what I'm trying to do, is to log in on the CITO server so that you can see this, how this is really happening. Oh. So now I'm live logged in the assessment system, and you should be aware, I'm moving, you move with me?
Yes.
I'm teasing you. No, it's fine, thank you. The right screen is called test monitor. That's something that students do not see. That's what we just see at the moment. Merci. Hein? So the test monitor is, because I want to show you something, but it's not part of what students see. So you see, this is the test environment, facet, and within it you see a GeoGebra screen embedded, and in which we decided to limit the number of buttons here, because there was too much. That's a choice, of course. We want to have some presets that students get familiar to of buttons, because otherwise GeoGebra for 14-year-olds, 15-year-olds might be too complicated. So that you can just play GeoGebra here, I don't know. And the task here is provide an equation of the line through point C, which is parallel to the red line that you've shown already. Okay, I can play around to do whatever I want. This doesn't make sense, but you see that it works. And here's an equation window. And if I click on it, I get an equation editor. Again, we can choose as a test designer an extended or a limited equation editor. This is the middle one. It's not the most extended one, but not the most simple one either. Let me see the solution. Probably x over 2 plus 3. And now I don't know if you saw it, probably not, but now the test monitor says that is correct. That's the ones here. However, if I do +1, +1, +1, it still is correct. You see again the 1 appearing? Now before you start believing that everything is correct, if I forget 1, it's of course a mistake. But if I decide to do it the other way around, 3 plus, and I decide to use this nice fraction bar, x over 2, then again it is correct. So there is a certain flexibility in entering algebraic expression, which is all recognized by the computer algebra system in the background, right? Second example, this is with the Freudenthal Institute's digital math environment. You see 2 graphs. Can you see them? They're not. I didn't choose the colors very well. You see 2 lines, and the task is, well, I can phrase it formally and informally. Informally is it design the sum graph of the 2 graphs. You see what I mean? And now I can, as a student, well, the easiest way is to think here, the light line is 0, so the sum is equal to the other, so it's this. Here the other one is 0, so let me count, Here, I guess. No, I don't think so. Sorry? I'm a bit confused because in my Anyway, you see what I'm doing? Let me see if it's correct. The test monitor says it's wrong. What did I do wrong? Right. Thank you very much. Thank you very much. So I'm going to remove this. Oop. And I'm going to... This was really stupid, huh? Sorry. Okay, and now... But anyway, you see that the automated scoring does work. But what I can also do is to start again and... start again. This test monitor is a bit annoying, but I needed to show you. And do some other points, like here, for example. This is going to be a point, I guess, and this is going to be a point. And again, this is graded as correct, you see? So there's a specific freedom because I can choose the points I want. Final example, probably from this live demonstration. Yes, please.
If the students have access to the test monitor for trial work, it could be used for formative assessment.
Sure. Yeah, right. Yeah. Thanks. Yeah. Good suggestion. Thank you. This one you can't read it, but it's 2 trees and a scarecrow is the English word, I guess. Épouvantail en français. And well, there's the treasure story, which means that the treasure is as far, well, the distance to each of the trees and the scarecrow is the same. And so the kind of technique that you have to do is this one. The question is, where's the treasure buried? There's to find the treasure, and the task says that the distance of the treasure to each of the trees and the scarecrow are the same. Right? So what you do is you do the perpendicular bisector here and here, for example, and you calculate the intersection point. Here we struggled a little bit with the number of buttons that we should assign, because, and we call the points P, for example. Because if you have two less buttons, there's not so much to choose for the students. So there's a choice to make as a designer. And again, what you can see in the test monitor, I guess, is, I hope, yes, I did it correctly. So this is how it works, and I think I will stop the, try to stop the animation here. Try to see if I can get out of here. Try to see if I can get out of here. So this was the example I showed you in direct. I'm not going to show you this again. This was in case the technology wouldn't work. What is interesting, by the way, is this. This is the command that we do have to enter as test designer, because we use Boolean variables in GeoGebra. And there's some mathematical thinking behind, of course, which is the most interesting part of designing such items. In this case, we also added a bit of tolerance. In some cases, you don't, because you have the computer algebra. So those are the choices to make, and we've seen this one. Okay, so I showed the Finnish case very briefly, the Dutch national examination case about graphing calculated to GeoGebra. This case about the digital intermediate test, or tussentijdse toets. And the final point is the Freudenthal digital math environment, and in particular the case of what we call domain reasoners. A domain reasoner is a those are built by computer science people, and it's a system that identifies rules, sets systems of rules and systems of buggy rules. And while interpreting student work, the system can detect whether the student applies rules correctly or applies buggy rules correctly, so incorrect rules, and can be used to design feedback. And the main point here is maybe also feedback on intermediate steps. And that's really a challenge. We have an Erasmus Plus project, Advise Me. The Pépite in Paris, the system by Brigitte Grujon, is also involved here. But I can give you a brief glimpse already. Oh, this is the more technical part for the domain reasoners. I'm going to skip it because I don't know so much about it. Here you see an equation. This might seem a quite complicated equation for like 12, 13-year-olds. But we do this with them because at the end it's not that hard. If you give them a mouse or a touch screen, you can say, well, okay, you see 27 over something very complex equals 3. So if I'm not too scared about this complex appearance, I can be aware that the denominator should be 9, thank you. So I cover this with my mouse or with my finger, and then this part is copied by the system, and I, as a student, enter, this should be 9, and the system says, well, at least this is not wrong. Now I have 8 plus something complex equals 9, so there's something complex should be 1, and you see how it goes on. Now this has nothing to do with domain reasoners, this is just equivalence testing, but we could improve on this by, for example, here you see a quite complex equation, and the right-hand side is what is generated by the domain reasoner system. So, independent, once that I implemented those rules, independent from the specific equation I enter, because I don't want to redo it each time, right? So, independent from the specific equation, I press this button and the system describes me how to solve this. And also it can, this is what you don't see on this slide, it can identify where I am and provide me with these type of hints, which are situation specific. So for grading intermediate steps and for providing hints, the right hint at the right moment, domain reasons may be very promising. Another example is this one. And in fact, it's the same system that generates, in this case, different feedback. So if we manage to build those domain reasoners, and we are, this one is for algebra, but we are now, well, my colleagues are now building those for statistics and for geometry, then this seems quite promising for a bit more advanced feedback or for formative assessment or grading for more summative assessments. So in short, the opportunities concern dynamics, concern construction room, expressive opportunities, and intelligent scoring. So that was the plat principal. Now the criteria and the conclusion, and there will be not many surprises in that, I'm afraid. Criteria, what we want, and I base myself on this booklet, which is available on the Springer booth, but also open access online. What we need is a nice formula editor. We need something to use graphs. We need something for tables, and we need something for geometry. These are the type of tools that we should provide our students with if we want them to show that they can do mathematics. From the system perspective, we need what I would call an expert system to make sense of what students are doing in a more or less intelligent way. Intelligent in this case means like we would do it if we were a mathematics teacher who was grading this. And we need some student model to keep track of what the student is doing and where he or she is, especially if we want to have adaptive testing. Which brings me to my conclusion. We need digital assessment tools for mathematics that provide students with means to express themselves, like graphs, geometry, etc. Provide construction room so that they are not imprisoned, but that they can really breathe and do. And for test designers, we should provide them with means to design really a wide variety of rich tests and interactions, test items. If we want automated scoring, which has advantages and limitations at the moment, but for adaptivity and also for, well, large-scale assessment, there is some advantage here. We need probably something like computer algebra in the background. We need some dynamic geometry, for example, with the Boolean constructions that we have. And maybe we need domain reasoners for some more advanced work. And the challenge for us is, well, like I said first, let's not neglect the regular practices in our countries with respect to assessment. And let's make sure that the psychometric, which is usually well done in national tests and so on, that we add technical and our mathematics didactics perspectives to that, so that we really can make sure that digital assessment of mathematics is a step ahead instead of a step backwards, I would say. So we need, well, in fact, what I try to convince the policymakers in the Netherlands of is that to assess relatively easy mathematics, we really need hard, sophisticated tools like computer algebra, because what they say, computer algebra, this is only for 15-year-old kids. What are you talking about? I need it at the background. So we need hard, sophisticated tools for assessing easy mathematics, but for item constructors, we need easy means to tailor these sophisticated tools for the specific assessment purpose at that moment. And that's also quite a challenge. So, thank you very much for your attention.
That raises certainly many issues related to the digital assessment, and so maybe some of these questions will be also raised in the audience. So please, if you have questions, comments.
Thank you. In your automatic reasoning system you showed, how do you, I mean, you have bugger rules, but you may have rules that the student imagines that are not the ones you were thinking about. So how do you take care of this kind of reasoning?
Yeah, that's in fact a challenge. It's not so difficult to check whether the rules that the students use are mathematically correct. That's the easy part. The more difficult part is to set up the buggy rules that students come up with. And you can invent them from your desk as an experienced math teacher, for example, or you can get them from literature, but you should also get them from student responses and by analyzing it and then gradually build it up. So that's a kind of bottom-up way to design the domain reasoner.
My question concerns, Paul, with students using technology, and I have quite a lot of experience with examination authorities, but it's in the past using graphic calculators and computer algebra systems. And one thing I've found is that it's very easy to get rid of the easy mark questions, you know, because the technology does that, and so you lose the marks with it. And it's actually, even for people with well-intentioned who like the technology, quite hard to be creative without getting way too difficult for what kids are going to experience in an exam situation. So in your more recent experience, have you found ways to overcome these problems?
No systematic ways. It depends on the qualities and the creativity of the item designers, and that is challenging. What we do usually is we work with teachers who are engaged to design items, and those teachers, sometimes they come up with very traditional basic items which you don't like so much. Sometimes they come up with very creative examples that are far too hard. So they are field tested and they get a p-value of 10%, which means that only 10% on average of the maximum score is obtained. So we are looking for the people who can avoid the two extremes and walk in the middle. And that's not straightforward, that's difficult. Yeah, that's the art of item design, I would say. So there's no real solution to that. Sorry. Yeah. And what's also another aspect on this is once you have such a wonderful, perfect item, and if it gets public, for example, it's part of an examination, and for example, in the Netherlands we now are focusing on what we call mathematical thinking, which means like non-routine tasks. So we do include non-routine tasks in national examinations. But these examinations become public, and next edition of the textbook series, this task is in it with 5 similar tasks, which the students practice. So the next generation of students, to those, it's a routine task. So we have to invent another one.
Thank you, Paul, for this very interesting talk. So I saw that with domain reasoners in algebra, you had this manipulation, interactive manipulation of algebraic expressions. So how does that compare? I understand that reasoners go beyond this as statistic reasoners, probability reasoners, and geometric reasoners. But as for algebra, I mean, how does it compare to the epsilon writer software that Aristotle has written following A plus X that we've developed in the MC squared project?
Yeah, I'm sorry to say that I don't know exactly what epsilon writer does and doesn't, so I cannot really answer your question. But what is interesting in the domain reasoners is that, and I was not so clear to tell it, so thanks for your question. The domain reasoners are now, well, you were involved with the development, I think, in Math Bridge, or what was, so they are available. They are, in fact, not sure if they are open source, but at least they are available, and we embed them in the Dutch mathematics environment, but you can also embed them in other systems. So they are quite independent, and I think the epsilon writer thing is probably more close, isn't it? So that would be a practical difference, but on the content I cannot tell you, I'm sorry.
Yes, again, thank you very much. And I think it is the right way we have to go with assessment, and I especially appreciate to integrate different tools, for example, the dynamic geometry system, maybe also computer algebra system, like in the Finnish tests. But I also see some limitations, of course. I can ask you, where do you see the limitations if I think about a little bit more complex problems, not only modeling problems, but also problems you have to look for different solution strategies and you can use. And so where do you see the limitations? And maybe there is a two kind of examination in the future. We have on the one side this kind of assessment tests, and on the other side more maybe paper written or some other tests.
Yeah, well, to start with the latter, Hans-Georg, they have in Finland, they also, what I showed you in Finland was only the second part of the examination. They also have a written paper pencil basic skills part before that. So limitations, yeah. There are, of course, many limitations, and I showed some non-examples. My main concern at the moment are not the limitations, but I try to push the obstacles that we suffer now from a bit further. So that's my position. And I do have the impression that in Sweden, Norway, Finland, where they have this computer algebra dynamic geometry system part of the examination, that they do struggle with the type of task. Maybe in Denmark, Niels, you can correct me if I'm wrong. So it's not so easy to have really nice tasks that really assess the type of mathematical activity that you want to access, while students have access to all those tools. So, and for the 14 to 15 years old, that was John's question, I found it not that hard to go just a little bit beyond, to take a little bit of a helicopter perspective on what students do in the age of 12 to 15 and to design tasks for that. I think we managed quite well. But for the 18 years old who have all the tools available, my impression is that in many countries people struggle with that. So that's maybe the first short-term obstacle, is how do we design really good tasks for that level with those tools? You have a solution.
No, but that's no solution. Sorry, but is it really the criteria if we can have all the digital tools available? Is it just not only the question to create good tasks, independent from the question if you have the tools available or not? So my point is, I think it is wonderful to have these tools for learning mathematics, and of course then we also have to make them available in the testing and the final examination. But whether now the task is much different to a task where you do not have the digital tools, who cares?
Paul, I think that it's inevitable that once you so drastically change the repertoire of tools that students have at their disposal, that I guess it would affect the type of tasks that you would.
Paul, could I ask you a question? It's Richard. Hi. First of all, thank you for your talk. It takes a lot for me to be excited on the talk about assessment, but it was exciting. I want to ask you a question which maybe you'll tell me you're the wrong person. I should ask a politician or somebody. Most of the mathematics which is actually done in the real world by real people is applied mathematics, not pure mathematics. And one of the reasons I think why in the field of assessment, and especially automated assessment, has focused on pure mathematical questions like your equation solving and so on, is because it's much easier. But on the other hand, we do now have, in this beginning of this new century, it's still quite new, the opportunity to make mathematical assessment much more realistic, in the sense that it can be about real things, about modeling and so on. I realize I don't have to convince you from the Freudenthal Institute of these things, but I wondered if you have any experience of using automated assessment for mathematics, which is the real thing rather than artificial.
Well, thanks for your question, Richard. But I think that, for example, in the Scandinavian countries, I do see some examination tasks that really focus on modeling and so, but they are all have human grading. So if you want to do that, assess this with automated scoring, I think that's at the moment a bit beyond beyond what we can do. So I agree with you, and so the automated scoring at the moment is still quite basic. So you can use it for adaptive testing and so on, but not so much, I guess, for these higher order goals that you mentioned. So for that case, I think for the moment I would prefer human grading. And then you can do it. That's what we do in Scandinavian countries. They have modeling tasks, and students can decide to use GeoGebra or Inspire or whatsoever, or Scratch on their screen. So there are a lot of opportunities, but not if you want to do automated scoring at the moment.
Thank you. Oh, sorry.
So, hello. Thank you for the talk. So my question is, when it comes to digital assessment, how does the teacher deal with the students' mistakes? So, for example, well, I was always told that I would learn from my mistakes. I actually do, but most of the time I just skip the correction of the test, which is bad. But when the students make mistakes, how is this taking what kind of trace does the digital assessment software keep for the teacher to, let's say, kind of detect what went wrong in the student's reasoning?
Yeah, depends on the system and depends on the setting of the system. What you can do is there's this idea of student modeling. Student modeling means that you clearly describe the domain of knowledge, like algebra, geometry, or whatsoever. You clearly describe it, and you link your items to this what they call domain model. And then, as an overlay, you keep track of what students do. And keeping track, that means logging, and this can be on different levels. You can log at a very detailed level, so that if a student types an X and then there's a backspace, I can know it as a researcher if I wish. In our digital math environment, we have very detailed logging mechanisms. You can even wonder if it's ethical to register what people want to erase. But anyway, so there are different levels. You can also just keep track of the different answers students after pressing enter or so. So there are different levels of logging. And then you can try to you use this logging to inform the student model. And you can then generate feedback either to the teacher or to the students at different levels of sophistication again. So that's the very general answer. We are now working on a system for statistics courses for first-year students at university. And they will get back a kind of diagnosis with respect to the statistical content. And that works like this. There's what they call learning curve analysis, which shows also the different, how do you say it? The different responses when students try to improve. So they enter something, they get feedback, it's incorrect, and then they try it again. And also you can, of course, provide more detailed hints and suggestions to students. So there are really different ways to keep track of that. Does that react to your question? Okay. Again.
Yeah, just thinking about Richard's questions about modeling. Of course, we all like the modeling problems, and we'll do it in lessons. And if we do it in the examination, I see in the maybe already the last years, they are very artificial problems. They are not real modeling problems. Yes, you have to go many steps back, and so you don't really recognize the original problem. And I'm a little bit afraid if you do it in the automatic testing, there is another step thinking about what is possible in this automatic testing. And this is, to me, it's the danger, yes? Not seeing the problem in front, seeing what does the system be able to manage which problems, and to see what problems are possible for the system. And the way should be the other way, or it should be the other way around. Yes, first to have the examples and making the technology able to come along with these problems. And I think this is one step in the right direction, yes, to have more facilities, more computer programs available. Yeah. But I see this danger.
Thank you. But if I would want to assess modeling, I wouldn't use a fixed time test. I would say, okay, the four of you, you're a group. This is my very complex open modeling task. You have 2 days to work on it and use all the tools you want and ask anyone you want and come up with a nice report to advise me or something. So probably you need different. My talk was mainly about the traditional fixed time tests individually, and there are other formats of assessment that are much more suitable. And in the Netherlands, we have a system which I like, which means that the national examination accounts for 50% of the final grade, and the other 50%, it's up to the school and the teacher to decide what they do. So they can deliver this type of modeling task and say, this is the other half of your final examination, of your final grade. Unfortunately, they don't do it, but that's another point. They can.
One more question.
Well,
one of the things that can be done, and it needs exponentially more energy and time put into it, but who's in a hurry, is to think about doing these kinds of tests for modeling. So part of the modeling activity is that it's unpredictable, or it may come to different things, but there may be a way to think about right and wrong answers and questions about specific models and specific activities and specific representations and ways they are connected. It just needs a different granularity and a different order of magnitude of effort put in, because you have such a big diversity of models, of course, and everything like that. So you can't just make one size for all perspectives on the problem. But maybe that might be a way in, I'm thinking now.
Yeah, but modeling also, I guess, requires some kind of creativity and some nice ideas and things that are difficult to come up in a stressful, limited time examination setting. So I'm not sure if, but you could do some efforts, of course.
So actually, I'm not saying that France is very good at lots of things, but in this 18 years old exam, we have this kind of report. So during limited oral examination, there is a report of what was done during the whole year by a group of 3 or 4 people. It's TIPE, and I think it's very productive.
Yeah, I imagine. Thank you.
Other question?
I think about Italian examination, and I think about the difficulty of of many high school professors to accept, for example, Invalsi test or Oxe-Pisa test, because they say that don't allow about the student to speak their thinking, their mode to explain how they have this result, and so on. How we can have a medium from open questions, normal open questions, old open question, and digital assessment in the future.
Yeah. Well, I don't know. What you can do, for example, in this Finnish system, students can combine written text, formulas, calculations, graphs, so they can write down a mathematical story, so to say, and a mathematical line of reasoning. But then again, you need human evaluation, of course. So that's what you can do, and that's what's done in some places. I think students need to get used to this, to use these media to really set up some reasoning and some proof, for example. But that can be done, of course, yeah. But it can also be done in an oral examination, like Christian mentioned.
Still questions?
Thank you, Paul. In your opinion, Paul, do you think this external evaluations, assessments that you showed us could have an impact on teachers' practices, and how?
Well, of course, because as a teacher, you want your students to do well, so you do want to prepare them for examinations and assessments. So, yes, there's a bit of an obstacle in a sense that once you work with big banks of databases with items, then usually you want those items not to be released. So that's a big issue. For example, in the Netherlands, there's a lot of opposition against keeping items secret, so that students do not really have insight in what they've done, and teachers sometimes do not really know what to expect. But of course, assessments and examinations are big levers for educational practice and change. But then teachers should be able to know what's going to be assessed and how. So there's a bit of a tension there.
I think that we can stop the discussion unless you have a very last question. Otherwise, we can thank again Paul for a very interesting talk.